Okay, good afternoon, everyone. Again, my name is Lou Hutter, and I'm the General Manager for the Analog Foundry Business Unit of 동부하이텍. So what I'm going to do is give you a little introduction to several speakers that are going to be part of my team at the Analog Foundry, and we're going to show you some of the technology that we're working on. So what I wanted to do was just give a little bit of an overview before we start. So what I wanted to do was just make a comparison of the current situation in the industry between digital and analog. And so if you look at the digital, one thing that's pretty clear is there is the ITRS, a roadmap. There is a well-established, very well-published roadmap in the industry for digital technologies, and it tells you pretty much when you need to be at what node, and so everybody, they shoot for that node. So as a result, really, technology is not so much a differentiator anymore in the logic space. Really, the timing and the ramp execution, how well you can get the yield, are really your biggest differentiators. And so really the differentiation is done in the product space primarily. That's where the intellectual property exists on the digital side. And right now, as we've talked about earlier today, much of the technology development now in logic is really done in the foundries. You're seeing more and more of the IDMs going fab light and moving and depending much more on the foundries for that. Now, if you look at the analog, it's a very different situation. There is no ITRS roadmap. And so as a result, the technology is still a very important part of the IP in the analog space. So not only is product design IP important, but the technology itself is very differentiated, or can be very differentiated in his IP. And one thing also that's very important in the analog space, there is a high level of collaboration, of joint working between designers and technologists to develop products. And historically, analog has been really dominated by the IDMs. But more and more, you're seeing that gap between IDMs and foundries is closing, and I'd like to think that we're doing our part here at 동부하이텍 to help close that gap a little bit too. So let me talk about some of the trends that I see from a technology space. Really, interestingly, there's almost, you could say, two opposing trends. In one case, you have what I'll call analog and power system on chips. So you have a very high effort to integrate, to try to take everything that's not digital and cram it onto one analog chip. And so there you're really driving for cost and efficiency. But on the other end, there is a growing emphasis on very high performance products, which are standalone type products, because you're trying to get the very best performance. And as someone earlier said, a lot of those cannot be integrated quickly onto into a system on chip, so you try to build the very best and you have it standalone. So really you have two kind of almost opposite type of roadmaps. From a voltage standpoint, in the analog space, there's really very little voltage scaling. In fact, for some applications, you actually see the voltages rising. Certainly digital content is increasing. If you look at the digital gate count over time, it's certainly increasing. It's much, much less than what you would see on a digital chip, but certainly it is moving upward and to the right. Also, the non-volatile memory content, that is certainly something that you see more and more of. Originally, you saw a lot of effort for trim, just simple trimming, post-package trim, but more and more you're seeing microcontrollers on board and much more sophisticated storage mechanisms. And then finally, it's very clear that power management is a very big growth area, and you're seeing much more power on board, And so that is driving the need for much, much more efficient power devices over time. And so anybody that's working in the power area is really driving RSP much lower, as Taylor mentioned earlier. So last year I was at this Leaders Forum. I'd been here maybe about a month and a half. And so I took a look at what our technology portfolio looked like, and this is what I showed. I picked the same slide that I had last year. This was in the third quarter of '08. I look at the world of analog in 4 quadrants: power by CMOS, and typically it's maybe a high voltage 60 volt process and a 20 volt low voltage process. A lot of components, lateral DMOS, drain extended devices, lots of analog components. And then you have what I call density analog CMOS, which is many of the same components except not so much emphasis on the power. Then I look at very high performance analog CMOS, where you're trying to build very, very best in class type components. And then finally high speed by CMOS. And so I rated us at 동부하이텍 according to these colors. I thought we were good in 60 volts. We had no 20 volts. We really had not much in the analog mixed signal space, and not much here. So we've worked very, very diligently over the last year, and I'm here to tell you that I think we have really extended our portfolio significantly. We're greener than we were last year, if you will, in the 60 volt space. We've added some good technology. But we are now bringing out very capable and leading edge 20 volt capability, as well as a mixed signal analog process that really is modular with respect to this. And this one is yellow, meaning that we have started working in high performance space, but we're not finished yet. Now, we still haven't addressed the high speed by CMOS, but this is keeping us pretty busy, so we're focused in those areas. So just to give you a little bit of feel for what will come later in the next couple sessions, this is a look at the 0.18 micron BCD technologies. And I won't really cover all of this, but you can see that there's quite a bit of components. We'll talk about this in the next session. But here is a 60 volt technology looking at the specific on resistance versus breakdown voltage, and the bottom one is more of a low voltage process. And you can see I'm comparing us with IDMs. I'm not comparing us with foundries, because typically IDMs have been the leaders in the power space. And my goal is to be as good or better as the IDMs, because my fabless customers have to compete against those IDMs, so I have to be as good as the best. And so you can see that we're doing quite favorably and very aggressive against some very reputable IDMs. So we've set our targets high, but we're moving to execute and to deliver some real high quality leading edge performance. So the last thing I wanted to talk about before I turn this over to my colleagues is, if you're going to be in the analog space, you have to think differently. It is a different culture than the digital or the memory space. And the first thing I would say is you need what I call silicon accuracy. You need lots of components because analog requires it. Designers expect it. But there's a big focus on tight distributions, extensive characterization of components, looking at second and third order effects, matching, noise, temperature coefficients, voltage coefficients, all these things that can take a good device, and if you can predict them, can turn it into a great device. Then the next thing is, once you've measured all of this, it has to find its way into your simulation tools. Okay? Because as far as a designer is concerned, what they see on their CAD screen is the technology. If you measure it, but it doesn't go into the models, it doesn't exist. And so your models have to match silicon, your PDK needs to work, and ESD typically ESD is one of the main reasons products don't go to market on time. And so a real focus, if you're going to be an analog and you're going to be in high voltage power, you need to focus on ESD. And then finally, you're going from the silicon space to the simulation and finally into manufacturability. So clearly you have to have tools available for electrical failure analysis, ESD reviews, a real focus on zero defects and how do you work DPPM levels. I think these are the kind of things that you need to be able to ramp this technology successfully and quickly. That's what your customers demand. So I guess finally what I'd say is if you want to be in this space, a foundry needs to think and act like an IDM, because effectively that's what we are for fabless customers or for any customer. We are their fab, and together, I think as the previous speaker said, you have a partnership between fabless and foundry, and we together look like an IDM. So in conclusion, as I've shown and as you'll see in the next several sessions, we've made significant additions to our technology portfolio since last year. I think we have developed and are developing aggressive technologies, and our goal is that the performance will be as good as the IDMs. But we're not sitting still. We're working on what's next, what's new processes, how do we continuously improve and build even more robust technologies. And I guess the one thing I'd say is from the analog foundry standpoint, we're totally focused on analog. I mean, I get up in the morning, I think about analog. That's what I think about when I go to sleep at night. The vision that we have is, and the vision that I tell every customer and every employee, is our vision is to be the most respected analog foundry in the industry. And we're not there yet, but that's our vision and that's what we work on. Okay, thank you very much.